Good evening, everyone. Welcome to Let's Talk with Tammy, brought to you by Bikina Resources. Bikina Resources is a comprehensive consulting company in working with individuals, businesses, school, government, and organizations. They have a 10-year-long track record in conducting seminars, workshops, and individual series on personal branding and appearances. For those of you who are tuning in for the very first time, this show features interesting personalities from all walks of life, sharing profound insights into relevant topics. And I'm Tammy, your host, and my basis for the show has always been about sharing my personal journey in learning anything that piques my curiosity. For today's episode, I think we already know what it's going to be about. We're going to be talking about the importance of science communications and the prevalence of infodemic on the current pandemic. So with that, allow me to introduce you um, Dr. Mahaletchumy Arujanan. Welcome, Dr. Maha. It's an honor to have you on the show.
Hi, Tammy. Nice. Thank you so much for having me.
Okay, so before we start, I think it would be a huge disservice to you and your achievements if I don't read them out. So please bear with me. Okay, so Dr. Mahaletchumy Arujanan is a global coordinator of the International Service for Acquisition of Agri-Biotech Applications and the Executive Director of Malaysian Biotechnology Information Center. Okay, she's also the founder and editor-in-chief of the Petri Dish, the first science newspaper in Malaysia, and the Asian short course on agri-biotechnology, biosafety regulations, and communications. She also co-founded Science Media Center Malaysia. Ms. Dr. Maha also developed the first science communication training module for scientists in Malaysia. She serves as a public participation and outreach strategy development specialist for UNFAO Sri Lanka Biosafety Program and adjunct lecturer at Monash University Malaysia and Ames University. Dr. Maha is listed as the world's 100 most influential people in biotechnology by Scientific American Worldview 2015. She's also listed in the honorific list of Women in Biotechnology Law and Regulation as part of the Biotechnology Report 2015. Dr. Maha won the 2010 Third World Academy of Science Regional Prize for Public Understanding of Science for Southeast Asia and Pacific region. She has published chapters, papers, and articles on science, biotech, communication, and biotechnology development. She sits on the Selangor Bio Advisory Council to provide advice on biotechnology development in the state, a member of the National Ad Hoc Biosafety Committee, Industry Advisory Panel for 7 universities, and served on the National Bioethics Council. Dr. Maha is also on the advisory board for Cornell Alliance for Science, Farming Future Bangladesh, Genetic Literacy Project USA, and Mustafa Science and Technology Foundation for Women. And I think recently you are also an advisor for the Civic Science Literacy, right? A project with World Organization for Science Literacy, which is based in Beijing. Am I right?
Yes.
Okay, so I think I really wanted to read all of that because it's very relevant to what we're going to talk about is to believe the right people, to listen to the right people, to listen to the experts, right? And I think it's enough for me to have someone of your caliber on this show, and so that I really hope by the end of the show, people would actually listen to what you are going to try to convey on the problem that we are having in regards to misinformation and disinformation regarding science. So I think let's start with the basics, which is for the benefit of the audience. Could you define what science communication is?
Thank you, Tammy. First of all, thank you for having me, and thank you to all those who have tuned in. And we really hope that this will be beneficial to all of you. And please, be free to be interactive. I love interaction because I'm a science communicator, so you can just ask any questions. Now, I just want to, before I answer your question, which I've forgotten, please repeat later. But I just want to tell you that, or tell the audience that there's always a science link for those who are interested in science. So when Tammy approached me, I was thinking, why is she so interested in science communication? And I didn't really search her background, but when I spoke to her, she told me that she's a microbiology graduate. She teaches in Sunway College. So that is always the case, that someone with science background will always be fascinated by science. Now, tell me, what was your question? Sorry.
No worries, doctor. So basically, I think I want to start with the basics, which is, can you define what is science communication for those of us who might not know what it is?
Okay, now that is why I started with the background. So what is science communication? It is different. I always differentiate between science communication and scientific communication. To me, I make my own definition. Science communication is communicating science, concepts, theories, research to people who are not involved in science. That means non-technical audience. And who are these people? A lot of time we think all scientists are technical people. No, I'm a microbiologist. I'm a biotechnologist, just like Tammy, but an engineer. To an engineer, I'm a layperson because I'm not, I'm not an expert in engineering. I'm not an expert in physics. So I become a layperson to an engineer. So when an engineer wants to speak to me, he or she has to reduce the level of language, the level of difficulties, and make it very simple. So that is science communication. So science communication is communicating science to someone who is not in the same field as us in science. So who are these people? As I said, even among scientific community, there are lay people as well, because we belong to so many different science fields. Now, the others are policymakers, politicians, media, students, consumers, investors, religious scholars, farmers, lawyers, regulators. And so, the range is so big. Now, I also mentioned scientific communication. Scientific communication is what scientists always do. Go to an international conference in their field and speak to their peers. Write an article, write a paper in journals, in their journals related to their field, and communicate. Those who read are people in their field. That is scientific communication. So that's a long answer.
I think that's a great way to distinguish, because when it comes to communicating, there's one way to communicate with people of your same field and would easily understand the technical jargons that you would use, as you compare to with lay people who might not know many of the things that you're talking about, but the information still should go to them. They should still know what are the recent advances in whatever new findings that the scientists may have found.
Yeah.
So we have seen, you have explained to us about scientific communication, science communication, and how are these two different from science journalism?
Okay, science communication is a bigger field. Science journalism is a subset of science communication. So science journalism is writing or producing material for mass media. Or even now, we have got digital media, we've got online media. So anything you do with journalism, you are communicating to your audience in mass media or digital media. That is science journalism. And I would say science journalism is a subset of science communication.
Right. Okay. So I think, but nowadays, do you think a journalist, especially when it comes to scientific information, is very, very easily, misinterpreted, So do you think a scientific journalist should have scientific background?
Not necessary. This is, in fact, we had a debate, a discussion in a local university, which is going to introduce masters in science communication. And some of them said, those who do these masters must come from science background. So the same with journalists. Do these journalists who want to write in science, must they have a degree in science, any fields of science? I would say no, because before I came into science communication with my biotechnology masters in biotechnology, I was very biased about science. I always saw science in the lenses of a scientist. Now, so it is good to have science communicators, science journalists from different background, because they are more neutral. They don't have this kind of sense of attachment to science, but they are more neutral, and they also know how the public think. What will the public be interested in? What are the values that influence public trust, public concerns, and public perception? So they actually have all these things compared to a person who's trained in science. I had to walk my way and really get myself drowned in science communication to understand all these things and leave my biasness behind. So I would say, to even whether it's science journalism or science communicator, this field is open to anyone, as long as you have some basic science knowledge. You don't have to have a degree, but you have the curiosity, and you're willing to learn, and you're willing to communicate and get that, dig out information from the scientific community. Then I think this is open to anyone. And in fact, there are advantages for people who are not in science to come into this field.
Okay. I'm also curious, doctor, because I think until you came out and talked about science communication, I don't think many, even as a science student, we were aware that such program or such postgrad degree exists. I mean science communication. So how did you stumble upon science communication, and what made you got so interested in it?
Well, I wouldn't say I was the first. Maybe I started popularizing it. So
Yes.
there were
Yeah.
already road shows done by Ministry of Science. They went to
Mm-hmm.
schools and they got school students to play board games and do extraction of DNA and many things. There was already there, but it was all done in an ad hoc manner. So sometimes
Right.
they have funding, they do it in a big way. Some years they
Mm-hmm.
don't have funding, they don't do it. And many scientists, there were scientists involved, but it was more on voluntary basis. Until now, it
Right.
is something like that. But when I got involved in this field, I was really fascinated because there's a huge gap between society and the scientists. And when I say society, I mean all the stakeholders that I mentioned: politicians, policymakers, investors, and so there's a huge gap between the scientific community and all these stakeholders. So
Mm.
I saw that this is a field that is so important because, I like what Sir Mark Walport says. He was a former UK scientific advisor, and he says
Okay.
science is not finished until it is communicated to a wider audience. So if you
Right.
do some work in the lab, you publish your work in journals, it is not completed until it reaches a wider audience. So I
Right.
really liked it. So when I joined Malaysian Biotechnology Information Center, at that time only as a project officer, uh, I was completely lost because coming from a science background, trained as a scientist, and I was doing biosafety policies, regulations, and putting all these things together, school children, I was completely lost. But as I picked up the ropes, then I thought, as I said, I thought this is a big gap. That's a big gap, especially in
Right.
developing countries, in Malaysia. And
Mm-hmm.
it is so exciting because uh, there is a lot of interest among the public in science. Only thing, we are not able to repackage this information, these messages, and this knowledge that will
Mm.
resonate with the public. So when I went deeper and deeper, I thought this is really exciting. And I want to tell you
Right.
that everyday life of a science communicator is completely non-routine. We have to
Right.
jump. Like just now, I was talking to all the regulators and policymakers around the world uh, in a training course organized by Michigan State University. From there, I'm jumping into here talking to lay audience. So every day is different. We change our
Mm-hmm.
language, we change our
Right.
approaches. So I got very excited, and that is when I decided to do my PhD in science communication.
Right, right. Okay, because that's such an interesting thing, because over the years, that's what I noticed as well when it comes to the gap. Like whenever there is some sort of information being distributed to the public, it's either too technical or it is simplified to an extent that the original message is lost. So I felt like there is some sort of regulation that needs to be done, and I think science communication is a great way to
Mm.
bridge that gap. And speaking about bridging that gap, okay, but before that, I'm seeing quite a number of people are watching, so please feel free to leave your comments and questions. Dr. Maha will be happy to answer your questions. Okay, so now we were talking, and you mentioned earlier about how science is not complete until it reaches the masses, right? And there is a gap. So currently, if there are scientific, if there are scientists in Malaysia who wants to, spread their knowledge and disseminate their information on what they just found. And of course, there's one channel which is the scientific communication. They will go to conferences,
Mhm.
present their papers and whatnot. But currently, is there a channel for scientists to release that information to public?
Certainly, Tammy, this is where I saw the gap, that there is no avenue for scientists to talk to
Mm.
the public, to talk about their research, to get public excited, to get policymakers understand why this research is important, and to get more funding. So that
Right.
is when in 2011, I founded the Petri Dish, the first science
Yes.
newspaper in Malaysia. And
Mm-hmm.
why is, of course, I explained why. Now you might say, why we can publish in all the mainstream newspapers. Now the
Right.
mainstream newspapers, there are hardly someone who understands science.
Mm.
Very few understand science, or very few appreciate science. Science pages, for the editors, it always falls on the blind spot. Advertisers
Right.
don't want to take advertisement on the science page. So for them, like, that is always a secondary thing. Now, why do you see virus and epidemiology and and ivermectin and all these things today because the pandemic. The whole world is talking about it. So
Yes.
now science come to the surface. Let me tell
Yep.
you, once the pandemic is over, science will be forgotten. So we don't want that to happen. So I wanted to create a mouthpiece for the scientists so that scientists can freely tell us that they want some space. So there is a space, the Petri Dish, and we are more empathetic. So if you send an article on your research to the mainstream newspaper, it'll if it doesn't meet their level, if they think it's that it does not have news value and their readers are not going to be interested, and if they themselves don't find it interesting, it's going to be trashed. But for us, we have the empathy for the scientific community, so we can save your article by editing it, and we have got a team who, my editor and myself, who will be able to do that. So this is a platform. Now, besides Petri Dish, I always say there is another media that no one controls you, as long as it is, you go by your guidelines, your institute's guideline, and our government's guideline that it should not be racist, religion, and sexist, and all those things. No one controls you, and that is the social media. It's a powerful tool where you create your social media, you garner your followers, and just do what you want. Talk about your concepts, talk about your research. But of course, scientists must understand, if you have not published your outcome anywhere else, don't put it in the public. Publish your paper, and then you talk to the public. Or you don't even have to publish. Scientists can just talk about any concepts, any theories, not detailed research. So, feel free to talk about all these things. So, there are avenues to do it.
Right. Okay. I have two questions. One is just a personal curiosity as a scientist. How do you vet the articles that scientists send to you? Because, sometimes you also have to filter out papers that are not of that good of a quality, right? And then that is one thing. And then second, do you think there is a way to lobby for a much more exposed scientific literacy through the newspapers? We have the business section, we have entertainment section, we have sports section. I think if we slowly start, like, even if it's a one-page thing, what was discovered today in science or something like that, wouldn't that be great? Is there a way for us to lobby for that?
Okay, you've got two questions there, Tammy. Let me answer the first question. How do we vet? So I have rejected papers. As you said, I think early on you said science, sometimes it's too simplified. I call it trivializing. So as much as science communicator like me will always say, simplify your research, your messages, but sometimes scientists, when we say that so much, scientists tend to bring the science, dumb it down, I would say. They dumb down the science so much that there is no excitement. We must understand science creates the curiosity among the public, and the public always sees science as something that's intriguing. So we need to keep that wow factor. So when that happens, I have to tell the scientists that, no, you need to build it up. So I have rejected papers like that. And sometimes very prominent scientists, they tend to make it so complicated, then I have rejected those papers as well. So, and sometimes the article, we also have to see, does it have a news value? As much as we are science newspaper, we have to also see whether there is a news value to that paper or not. So will the readers be interested? So sometimes some articles come from overseas and we say, I don't think my readers, this is relevant to my readers. So we have to reject as well. So we do that. Now, your second question was on, what was it?
If we can lobby for a section in the news.
Okay. Yeah. Now, Tammy, let me tell you, this is very difficult because editors are business people. Newspapers are run for business. TV stations are run for business. So this is very difficult. And that is why I really hope, the government, the agencies, and the scientific, the institutes, they will support Petri Dish so that we can sustain Petri Dish. Singapore, they were saying, wow, we didn't know Malaysia has got this. Even we don't have a science newspaper, and Malaysia has got a science newspaper, and it's very good quality. So, we already have the foundation. So I really hope more players will come in to support this so we can sustain it. We are actually bleeding. My team is working voluntarily for Petri Dish. So we are bleeding, but, it's a passion that we want to keep it going. So I really hope more will come to support the Petri Dish.
Okay. All right. And then Okay, so since we're talking about science and trying to make it very, very approachable and digestible for the public, but before that, maybe we want to talk about school and how do you think we can encourage more children to take up STEM in school?
Okay, I think, Tammy, before that, now we're talking about making science palatable, making science exciting, but we didn't talk about why. Why must science be, why the public should know science? Why should the public get interested? So you are bringing up children. Now, let me just give in a nutshell why the public, meaning all the stakeholders that I've mentioned, they need to take a look at science and get, give some attention to science. Now, let me say, can we think about a country in the world that has achieved a developed nation, but their science, technology, and innovation is not a priority?
Of course not.
Yeah, right. So all the OECD countries, their science, technology, innovation is very strong. Their investment budget for R&D is big, so much bigger. Their percentage to GDP is very, very big. So you see, all the countries have reached that economic status and even the social status because of science and technology. So for that to happen, we need good policies. And I can tell you, Malaysia has got excellent policies, very nice policies, all shelved in all these government agencies. How is it implemented? This is where we need to so much needs to be done. So, the implementation, why the implementation is not really great? Because our policymakers must understand science. They must understand how to implement it, why it must be implemented in a certain way, and they must understand all the different areas of science, whoever is assigned to do all these things. Our politicians must understand science. Now, let me give you one example: genetically modified crops or genetically modified organisms, genetically modified food. Now, this is a big tool to ensure food security and sustainability. But there are many policymakers, there are many politicians who are against it. So how can we ensure that Malaysia becomes, food secured if we want to stifle one of the potential technology? And why is it so? Because their knowledge in this area is not sufficient. So you see, science communication is important to have good policies, to implement it, and to have good regulations that do not stifle development of science. And so and that is all policymakers and politicians. Now, you spoke about children. And we know not only in Malaysia, in many countries, there is a decline in students wanting to pursue STEM education and later on STEM careers as well. So we need to inspire these students and tell them how fascinating science is, what are the careers available, what can they do, what is out there for them. So for that, we need to talk about science so that they feel, hey, this is exciting. I want to do this. I want to do engineering. I want to do physics. I want to do mathematics. So that is another reason. Now, the other one is, I would say, utilitarian. So now look at ivermectin. People are rushing to buy ivermectin. People are rushing to buy self-test kits to test their antibody levels. Now, to me, it's not important. Ivermectin, one, it's not proven. The serology test, it's not accurate. And it will not give you the real the real indication whether your antibodies are there or not. Now, I'm not going to go into the details of it, but why? Because the public do not understand. So this is where utilitarian, public to make informed decisions, we need to communicate science. Now, the other one is, can we make science as a leisure, as a passion? Instead of saying, I want to go shopping, window shopping, makan, which is our culture, can we say, I want to go to the science center? I want to go to, we don't have science theaters. I hope we'll have science theaters. We have science cafes, where before the pandemic, I know groups who organizes science cafes, where in some cafes where they invite science personalities and they talk about science. So can we have family activities revolving around science? Can we have science topics in kopitiam? Instead of talking about entertainment, politics, and sports, can we have science topics in kopitiams? Can we have the parents' participation in learning science? So this is where it answers your question. The children going into STEM, the parents must bring it up to the dinner table, in leisure time at home. So these are the reasons why we need to communicate science. So going to children, yes, it is very important, and it has to be done in a very creative manner, in a very inspirational manner.
Right.
Sorry for
So
diverting, Tammy.
no worries, no worries. I think you brought up a very important point about how no matter how much scientists fight for the truth, right? I think we saw this early on when the pandemic started last year, and how a lot of issues stems from policymakers or politicians not listening to scientists,
And
right?
we saw so
So
many politicians around the world saying all kind of atrocious statements about the virus,
exactly.
about the medicines, and yeah.
Yeah, and I think you brought up an important point that the policymakers don't have to be scientists, but they should be scientifically literate. And the
Yes.
way to make everyone to be scientifically literate is to ensure that science is a basic day-to-day conversational thing that we
Yeah.
do every single day.
Mhm.
And I this reminds me of that TED talk that you did, and you said, if we can have celebrity chefs, why can't we have celebrity scientists? And we do have some in the West. We have
Mhm.
Bill Nye, we have Neil deGrasse Tyson, but we just
Yeah.
don't have anyone here.
Yep. So
Yeah,
we need celebrity scientists, and we also need them as role models, as you said. That's children
exactly.
who, so the children feel like, I want to be like, you see, uh, when we put a white man, a white lady, it's not easy to relate to them. But if we put
Mm,
Professor Amina and Professor Sheila or Professor Emily, so we can relate because they are our kind. So we need more local celebrities or role
right.
models, mentors who are on the public domain. I
Yeah,
forgot to
yeah.
mention another one more reason why we need to communicate science, and this is very important for scientists. Now,
Mhm.
scientists cannot commercialize or bring what their research to the public unless it is put in the public, because you see, we need a lot of funding for commercialization, and
Mm,
funding will not only come from government agencies, it comes from many sources now, crowdfunding, and high net value angel funding. So, and these people, industry funding, and these people are not from science background, so they're not going
right.
to read the journals that we write. So for them,
Yes.
we need to put science in the media, in the public domain, so that they know, hey, there is a potential science that can be commercialized. I want to invest in it. And so
Right.
this is where industry collaboration comes in. So this is where
Mm,
scientists must really, start communicating science and engaging other stakeholders.
right. Okay. So do you think every scientist should go through this science communication course, or some sort of a crash course? Because sometimes I mean, I'm saying this as a scientist, if I'm not stereotyping scientists, but majority of us are not really someone who is willing to be out there talking to people. We prefer to just, sit in our labs and do our lab work every single day. So in order for us to be able to communicate and, get investors in, get people to invest in our projects, to have collaborations, do you think scientists, I think as long as I know, when we do our postgrad studies, the basic thing that we do, we learn research
Mhm.
methodology, but we don't actually learn anything about scientific communication or science communication. So do you think that should be something that should brought into all the postgrad modules for our future scientists?
Okay, Tammy, let me steer. You didn't do that job. Let me do that job. Let me
Okay.
stereotype scientists. Now, as a science communicator, I can tell you this is not a problem in Malaysia. It's a global problem where
Mm,
scientists are not trained to communicate in a
right.
layman language that suits the public. So,
Mm,
scientists are not good communicators because, for
right.
years, we can't blame them, because for
Mm,
years they have been doing this work, which is very high level. And how do you translate so many scientific terms to layperson language? So this is
right.
it is very difficult. So yeah, you rightly pointed out that they need training. So what I would, I have got a long wish list. What I would say is to introduce science communication module for every STEM degree program. So it could be
Nice.
pharmacy, engineering,
Mm,
maths, biochemistry, biology, or any science degree program. Uh,
mm-hmm.
at least one unit of science communication to be introduced, included into their degree program. That is one. Now the other
Mm,
one is, now a lot of institutes are I go and train many universities, I go and train many research institutes. So a lot of research people are already seeing the importance of science communication, but it's not happening very regularly, and very not everyone is doing it. So yes, we need to train scientists and researchers to communicate science. So I think this is really important. So this could be added as a KPI for scientists. How many training have you gone, and how much of engagement have you done? So I think this has to be like a KPI for scientists.
Right. Yeah, I think, okay, when you think about it, that'll be amazing for a scientist to, to probably successfully conduct a roadshow or something like that, to fulfill a KPI, to at least communicate what the scientist is doing as their postgrad program, right?
It's only fair, isn't it, Tammy? Because the research that most of the scientists, whether even you can be in a private institute, but still your research funds come from MOSTI, for example. These are taxpayers' money. So tell the taxpayers how the money is spent, what is the impact, and how far have you gone in your research. So I think it's only fair.
Yeah, I think that'll be super fun to see scientists having roadshows as part of their, you not only have to do your viva and present your technical presentation to your supervisors, you also have to do a roadshow where, layperson would also understand what you're doing for the past 5 or 7 years in your PhD program. So, okay, that is one thing, to induce the interest among students and things like that. But we also have to think about the fact that, when it comes to the labor market, when it comes to, high paying jobs, till now, I think the cliche is, okay, if I'm going to do science, I'm going to do two professional career, which is either a doctor or an engineer. Not many would pursue the scientific path, as in, continue with your postgrad, continue to do your PhD and then postdoc. Because, you need two things. Number one is obviously passion for it, because you're going to be studying for many, many years. And second of all, would you be getting paid, especially for students who probably would stop with a bachelor's degree? You would get a job as a research officer or something like that. But, when it comes to the pay, it isn't that lucrative, obviously, compared to someone who has a degree in accounts or finance. So what do you think we can do? Because it's one thing to have passion, it's one thing to have the interest, but at the end of the day, you want a job that pays well as well.
Now, true, I don't have one simple answer to this, and it is true many science careers do not pay as much as an accountant, but or other fields. But I cannot make a blanket statement. Science is always driven by passion and the passion to serve humanity. So, but if I would still say, if you can create a niche area for you and add value to your skill sets, there are many opportunities in science. You can even be an entrepreneur, a science entrepreneur. And I am talking to right now, I am interviewing a few entrepreneurs who are doing great job. And you can see later on these articles coming out in the Petri Dish soon, in a span of next week onwards. So there are so much of opportunities, but of course it's not a bed of roses and smooth sailing. But the journey can be longer. But I can tell you that these are fulfilling journey. Now, so to the question that the wage is lower, I can say not all the time, but yes, some can be low. And I think this is where the government have to step in and say this is the minimum wage for someone who is trained in science. If they really want to see STEM people going into STEM education and STEM career. And we made this proposal. This is still not disclosed. So we made this proposal in one of the roadmap that we wrote. I was one of the experts consultant in that, so I don't want to reveal much, but these are the areas that we need to look at. Now, you mentioned that no people don't want to do postdoc. Now, I would not encourage everyone to do postdoc. Postgraduate and then postdoc. It's not necessary for everyone. Now, do a postgraduate degree in science only if you really want to go that path, because many careers do not really require a master's or a PhD. Now, a PhD or a master's can be a double-edged sword as well. So if industry do not need a PhD and master's, they will say you are overqualified and we are not going to pay compensating what your qualification. So it can actually close some doors. So what I always tell science graduates is, first, go out, leave your university, get a job, explore the job market.
Right.
Let me tell you, getting a job is so much tougher than getting an offer to do masters and PhD. So
Right.
a lot of students, what they do, they go into this escapism route.
Mm.
Oh, I'm not sure what I want to do. They still very blur, and they're very scared to go to the outside world, to the job market. So they say, I'll
Right.
stay in the university, in this comfort zone within these four walls. Now I will say, leave the university, go and get a job, work for a few years, explore your areas, different areas in your within your training, and see where is the demand in the market. So if I see a demand, just like you see, I did PhD because I saw a demand. I saw
Mm.
my career will improve. I saw a demand not only in Malaysia, but I saw a demand internationally. And
Right.
my PhD added so much of value to me, and it opened
Mm.
so many doors. But I
Right.
did shopping for 7 years to see where I really want to do, where I
Mm.
really want to be. So the 7 years I was really searching from one job to another job until I found my career, my calling. So that is what I would ask them to do. A lot of people, students, just go blindly do a PhD, come out, and then they say, oh, I've got this, I've got that, but I don't have a job. Yeah, did you do a
Right.
market survey on where
Right.
is the demand? So that is what I would tell graduates.
Yeah, I think that's a very good point, because I've seen many students who have done that. I think there's also many videos being done to, slightly mock students who don't want to go out to the job market, and they feel like, you know what, rather than looking for a job, I might as well continue my postgrad studies, but not
Yeah.
knowing if this postgrad field is what the market demands. So that was a very good point. Thank you, Dr. Maha. So apart from all of this, okay, let's say there is, I mean, even if there is an increased interest in STEM, I think the one that really, for the lack of a better word, triggers me is that these days, most of the misinformation or disinformation that's being very prevalent in on social media is not because um, people don't know science at all. It's more like they know just enough science to twist it, so
Mm.
not, and that basically goes back to not knowing actual science or statistics, and pseudoscience, that part there where the boundaries becomes very blurred. They try to fit pseudoscience into science, market it as science as well. So how do you think science communication can help in this?
Now, so this is where you're right that a little bit of knowledge can be dangerous, right? But then we also, science communication is not about making our audience, our listeners, a PhD in our field. If I'm a microbiologist,
Right.
I'm not going to make another microbiologist just by giving, communicating science. I can't do that because
Yeah.
it's a field by itself. You need real skill sets, and you must really go from the foundation. So that's not the aim. But then, if our audience understands some basic science, they will be
Right.
able to discriminate fake news, pseudoscience, and real science. So this is what our aim is, so that we, when you read, and at least it creates some suspicion. So you see, we
Mm.
are all not experts in all fields, right? But if
Right.
something comes, even in not in my field, engineering or physics or whatever, it creates, if something is like a bit fishy, it creates some suspicion. I say, hey, is this correct? How can that be correct? So what
Right.
we do, we dig further, we go and look at the
Mhm.
internet and say, this is not right. So that is what we want to do. At least, the red light, where, hey, stop, I'm not going to forward this, because right now during the pandemic, what's happening is like what WHO said, it's infodemic, where you
Right.
receive something, you immediately want to forward that. So we
Right.
want to create the red light, that where people pause and ask question, is this right? Let me
Mm.
check. And even
Right.
that, they need some knowledge to, where do I check? You can go
Mm.
to the Google, and then thousands of search results pop up, and you must know which is credible, which is not credible. The way
Right.
people put their information and the way people identify themselves, you must know how to do this. So this is where some basic knowledge on science will help, and I think this is where science communication is very important.
Right. And I also think one way we could do it, because our textbooks and everything were somehow written or built in a time where maybe social media was not that prevalent, and where all information would be you know gotten from the textbook itself. But right now, it's not only the textbook. You literally have Google and you can find everything that you want under the name of research. You find everything yourself, right? So do you think we should include maybe just one topic in your science subject of knowing how to identify or knowing how to, differentiate valid sources and, like what you just mentioned earlier, being able to feel like, okay, this sounds fishy or this doesn't sound right. And that takes a lot of either experience or you should have some sort of basic scientific knowledge to know that this might be wrong.
Mm. It's not easy, Tammy, to have something like these are the guidelines. So when you, because it's so huge, the
Right.
pseudo fake news can be from any field. So we can't do that. So I think
Right.
the solution is to give science information and to have science. I mean, we already have in the curriculum. Science is taught until Form 5, even if they are in the art stream. Science,
Yeah.
there is still science there. But I always find that those who went to science stream, they have better ability to differentiate pseudoscience and science. I've seen
Right.
this a lot. So
Correct.
maybe the science in the arts stream also should be like ramped up a little bit. And and again, this is not, we can't do everything in school. I also disagree. Anytime any problems pop up, or sex education, put it in the curriculum. Road safety, put it in the curriculum. Biodiversity, put it in the curriculum. Climate change, put it in the curriculum. So this, not, we cannot overburden the children as well.
Right.
So what is necessary is doing something outside the school as well, either as co-curriculum, or this is again, as I said earlier, where the parents come in. If the parents read together and search together on the Google, discuss, and I say, hey, let's look at this. Is it really true? And this is parents' participation and even teachers' participation. I think this is the way to do. We can't put everything in the curriculum. And in fact, if you ask me, write up guidelines so people can differentiate. No, it's not possible.
Right. Yeah, I totally agree. And when it comes to all this misinformation, all this overload of information, especially now, like what you said, we have currently are undergoing infodemic. I mean, sometimes I find it worse than the pandemic. So how do you personally navigate all this news? Do you get news like that as well?
Oh, yes. Well, let me see. The thing with social media and me, I'm not in many groups. I'm
Right.
in groups where people don't say good morning, people don't say, hey, it's a Friday. So because I don't have time to, as you said, navigate and filter all these things. So I belong to
Right.
groups which are not taking so much of my time and putting all these things there. So that way, I'm not exposed to so much of all these things. But on the internet, and I do come across all these things. So what I do is, for me, it's simpler because the pandemic is also very microbiology, and so it's what we are trained for. So it's so much easier for me to have this suspicion: is it true? Like, you see, when there was also this conspiracy theory that the virus is lab made. Of course, it could be true, but then we also know it's not purposely lab made. It could be for some research purpose or whatever. So I'm not
Right.
going to go into that. But then, but there's so many journal articles that came and said it's not purposely made. So as someone who's trained in science and microbiology, especially, and biotechnology, I could really see why it is not purposely made. So it's not easy for the public.
Yeah.
But again, how can we translate those things for the public so the public understand, oh yeah, it is not purposely lab made. So
Right.
it's not easy for the public to really just immediately know what is right, what is not right. But then if they have, even they don't have to go like what I said was really high tech, molecular studies, and to say that this is purposely made, or how is it designed, and the genetic modification, that's very high tech. But then simpler
Right.
thing like ivermectin, I'm quite disappointed that the public are rushing to buy ivermectin, an
I know.
unproven medicine, a drug, not proven, not tested on human at all. How can they just do that? I will be so scared to put a drug into my mouth which is really not tested. So here I feel this is where some basic science will help. So they must
Yeah.
understand, not, of course, what the scientists have done is on the Petri dish. And what
Yes.
happens in the Petri dish is completely different than what happens in our body. In the
Right.
Petri dish, you can put the virus, you could put some Clorox, the virus will die. Does that mean I drink the Clorox? So,
Well,
you know,
someone did suggest that.
someone did suggest that, and that is why I'm bringing it. So you see, someone also suggested drinking hot water. Yes, heat will kill virus, but I can't drink anything more than 60 degrees Celsius,
Right.
70 degrees Celsius. So, this is where very basic science. I don't think you need to be a science graduate to understand this. So,
Right.
again, so yeah, I think I don't know what else to say.
Okay. And I think another reason why a lot of this news is spread is the whole problem with social media itself is that it reinforces what we already think. That's how the
Mm,
algorithm is built, right? When you search for something, you end up looking for something that will just prove what we just thought. That's how the algorithm works. So basically, social media is just like an echo chamber. It just reflects and resonates to what you are saying, what you think. And it's
yep.
very, very easy, no matter how ridiculous your assumptions are, you would find an article or two that supports your assumptions. And when there are people like this, and they feel like, okay, I've done my research, and here I have a couple of articles that says the same thing, right? So what can we tell to these people? Like, how do we tell them that, you can't do that? You have to understand how things work. You have to understand how algorithm works, and not everything that you read is is the truth. Just because it's out there on social media is the truth. It's the cognitive dissonance that's working.
Yeah, exactly, the cognitive dissonance. So, what we usually how the public perceive things is, you know how scientists work, right? We have to do long process, the methodology, and then repeat the methodology and reconfirm, and then we come to a conclusion. Now, how the public work is, they have a conclusion. Ivermectin is something that I must have.
Right.
Vaccines are not good.
Right.
Vaccines will cause, will alter my DNA. So how they search, vaccines will alter my DNA. And then, of course, all
Right.
what you said comes out. All these
Yeah.
crazy doctors who come up with all these crazy ideas and then say, yes, I'm right. So this is cognitive dissonance. So
Right.
we want to reaffirm, validate what we have, what our values. So that's what we
Mm.
always are. We always want to validate what, instead
Right.
of, we don't like confrontation. Our mind does not like confrontation. When there is a confrontation, we go back to our comfort zone and say, no, vaccines are not safe. So this
Right.
is what is happening. So what I would suggest to the public is, please go to WHO, go to MOH, Malaysian Ministry of Health, go to CDC, clinical, what's that? Uh, Drug control. So go to places like these. Even if you think vaccine is not safe, please go to credible sites and then look and then make a decision whether what you are thinking and what the real credible experts, after years of research, what they are saying. So I would suggest that, don't, please leave this. We are living in a time, very difficult time. And I must personally say, I am feeling very down, because last year it was, someone died in the newspaper. Someone died. We always heard on the newspaper, we read on the newspaper, we saw it on the TV. But today is my neighbor, my my relative, someone we know are dying. And we did
Right.
say, last year I remember saying in an interview that it will come to a point that every family will have a relation who is dying, or who is dead. And it's already come to that point. So we are living in a time which is very difficult. Please
Mm.
go by science. And we cannot waste any more time. So this is what I will say. So please put all your perception, your risk perception, how do you perceive risk aside, and please go by science. There's no time. We cannot waste any more time.
Right. I think you brought an important point. Number one, most people don't know how to Google. I think Googling is a skill in itself. Like when you want to find something, you need to find it in a very
The
neutral,
keywords.
Yes, you have to use the right phrase, the right keywords, and not basically put the whole tone of your thinking into that. For example, like what you said, instead of saying vaccine has 5G and you just put it there, that's literally what's going to come out. But if you
Yeah.
actually ask it in a question, what are the contents of the vaccine, for example? Okay, or is there any relation between 5G? How big is the 5G particle? Is it even a particle for you to even being able to inject to somebody? So I think that is one thing. People don't know how to Google. And then number two is not knowing which is credible source and which is not credible source. For them, as long as there is an article online, it is a source, and they don't really judge whether the source is, credible enough for me to listen to what they're saying. That's the two things I find very,
Mm-hmm.
very, yeah. And and then there's also another group of people who basically questions everything, even the words of scientists, because you just said, okay, if you want to find something, go to the WHO, go to the CDC, go to the FDA, and get information from them. But there will be people who will say, oh, they all have been bought by some higher people with money or big pharma who's trying to peddle vaccines.
Mm-hmm.
So, you are all sheeps for just listening to what they're saying and injecting yourself with some unknown substance. So what do you want to tell to these people who thinks so high and mighty of themselves? Who thinks they know better than all of us, who thinks they know something that we don't know.
Okay, this is the knowledge illusion. I think it's what Kruger. I can't remember the full. There's someone who suggested knowledge illusion. So we find scientists, social scientists, science communicators who do research. They found that among people, these are the people who have they think they are right, and they think they know the topic. They know vaccines. They know all these topics. So this is very dangerous. So it is very important to again go back to the credible sources. Now the conspiracy theory and linking everyone who has opposing views to them to industry. This is happening so much, not only in vaccine but also on all the drugs, in genetic. Because I'm a proponent of science, and when I talk about genetically modified crops, foods, they say,
Right.
oh yeah, she's being funded by all these big agri companies. So we get it all the time. So people must understand industry is not a demon. Now look at everything that you use. Why are people always singling out drugs, vaccines, and GM food, and not all the other things that has been monopolized?
Right.
Aviation. How many airlines do we have? Isn't it monopolized? How many? How many Microsoft do we have? So these are monopolized, and we depend on them. So why are we always singling out certain things that just because? And again, this is cognitive dissonance. We want to single out this because we don't agree with that. So industry
Exactly.
is not a bad thing as long as industry do not shortchange us. Industry is
Mm.
not a bad thing. Now, some people might say, how about patent? Now, patent is not a bad thing because people spend millions or billions of dollars, and patent is important for them to reinvest into the next drug. So, and if we are going to raise our bar and say no patent, no, we want all the safety tests, all the nice to know things about safety of GM crops, about vaccines, then we are making a big injustice to the public sector researchers, because if we want more public sector researchers to get into this field and create develop more drugs, and that we must not have our we must not ask all the nice to know things. We only need to know, we only want to know what we need to know about the safety measures. If we keep
Right.
asking all the fantasy, what if, all the ifs, no one can do research. And only those people with a deep pocket who can answer all the additional questions will be doing it. And who are they? These are the industry people. So can you see it works both ways? We don't
Right.
want industry to mingle with our drugs, with our vaccines, with our food, but at the same time we put all kind of barriers for the public sector to come into this space. So
Right.
this is where science communication comes in. Tammy, it's people all, a lot of scientists do think that science communication is about making science look fun, making science look fascinating. But no, for people like me, we go to, science communication is about policies, about patent, about funding, about regulations. So, these are the complexity that the public needs to understand.
Right. Thank you so much, Dr. Maha. So before I move on, we are almost reaching to the end of our show. So if you do have any questions for Dr. Maha, please do let us know. Write down the comments in your wherever you're watching right now, on Facebook or YouTube. Okay. So I think since we are in the topic of vaccines and ivermectin, so since people are watching, what would your advice be to the viewers watching right now on the importance of vaccine?
Now, I have said this so many times since the start of the pandemic, since vaccines were on the pipe in the pipeline, and now, of course, we've got a couple of vaccines. Vaccines is not new to us. We have been vaccinated as soon as we were born. 3 months, 1 month, 3 months, 6 months, standard one, and I don't know, standard one, 7 years, and then maybe in the secondary school, and then the girls, the girls are vaccinated when they're in Form 3 or what for HPV. So vaccine is not new. What is new, why the public has got all this so much of mental noise, is because now it's an adult mass vaccination. Usually it's a children mass vaccination. But, think about going overseas. I have a yellow fever vaccination card, and I go to Africa, I go to Latin America, and without that, I will not be allowed past the airport. So it's not new. The Muslims get vaccinated for, what is that? I can't remember the vaccine. For, I think it's some, I can't remember the vaccine, but they get vaccinated before they can enter Mecca. So this is adult vaccination again. So it is not new. And vaccines are not new technology. Even the mRNA technology is not new. People say, yes, mRNA vaccine is new, but mRNA technology is not new. It is as old as 30 years. So there's nothing to be afraid. And there are no shortcuts. People will ask, how come it has come out so fast? Because of the pandemic, all the agencies came together. They were able to approve it faster. If not, they have to wait for meetings. All these meetings happens once a month. So all the applications will be there, and then once a month the committee meets, and then they say, okay, you can do this, you can do that. But now, because of the emergency, the decision makers were meeting more often. There were investment pooled from all the countries together to make the vaccine, and there were volunteers. Vaccines need any drugs for that matter needs a lot of thousands of volunteers. But during the pandemic, there were ready volunteers. The healthy ones, the sick ones, they were ready volunteers. So all these things have made the development of vaccines even faster. So no shortcuts, no cutting corners, and vaccines are not new. Nothing. I think that for me, there are only two things that can save us from this pandemic. One is the vaccine. The other one is the SOP. All the SOPs, the distance and the mask, washing hands, no hugging. So all these things these are the things that's going to save us and put the pandemic to an end.
Right. I also want to new variants is actually due to the fact that people are getting vaccinated, and that is why the virus is mutating, and that is why we're getting various variants. So would you care to just explain to people who might think of it that way?
There's no way, if you're vaccinated, you're not vaccinated with a virus. Even if it is attenuated, the virus that is being used as a vaccine, it cannot replicate. So if the virus can't replicate, there's no way it can mutate in our body. So that's one. So the variant, in fact, the opposite is true. If you're not vaccinated, the virus is going to go into your body and it's going to mutate before you can even spread it. So what came in is going to be different than what you're going to spread. And we must understand this is a RNA virus. Before this, I think DNA was a vocabulary already. People know, DNA is my gene. But today, everyone seem to understand RNA, but I hope they understand it well. RNA is different from DNA, although it is also a genetic material. RNA virus mutates 1 million times faster than DNA organisms. This is the problem with the pandemic. If it was a DNA virus, the pandemic would have been over by now. It's an RNA virus. It mutates very fast. And how it mutates? Because it's spreading very fast. So if we stop the spread, now if there are viruses around me, but I'm vaccinated, it cannot really attack me, or it can only attack me in a very mild way, and then immediately when it attacks me, there's no time for the virus to really has a huge load in me, then the virus will not mutate, right? Because
Yeah.
my memory cells, my immune has got memory because of my vaccination. So what will happen is immediately my immune cells will know, they're already trained to produce the same antibody. So they immediately produce the same antibody. And before the virus load becomes so high, the virus is already killed. So there's no time for this virus to mutate. So tell me, compared to what public perceive, the opposite is true. The more we vaccinate the people, the more the virus is going to be an orphan, because virus needs host, right? It cannot replicate outside. It's impossible for virus to replicate outside on the table. It's not a bacteria. Bacteria can replicate in the soil, on the leaf, and everywhere. Virus need a host. So the faster we all get vaccinated, the lesser the mutation. We're going to bring down the mutation. So that is why vaccination is so important.
Speaking of which, I have another thing I would like to ask. There are people, however, who, because, at the end of the day, we are not strictly imposing everybody to take the vaccine. We are advising everyone to take the vaccine. So do you think that is okay? That is one. Okay, because yes, we are not forcing everyone to take the vaccine. Of course, everyone has to, everyone should, but we are not doing it, compulsorily. And also, we are now, as states are slowly reopening, borders are reopening. There's going to be some sort of a double standard happening. Okay, you can only dine in if you have the vaccine passport, and you can only travel if you have the vaccine passport. And some people are calling it a human rights violation. Some are calling it vaccine discrimination. Some are calling it vaccine appetite. So what is your comment on that?
Well, so many experts have spoken about this. Many experts in our country have spoken about this. There's divide views on this. I would say it's only fair for those who are vaccinated to have more freedom, because they are not going to be infected. Even if they're going to be infected, it's not going to be severe. But we must remember, those vaccinated, if they are infected, they can still spread. But of course, they can quickly recover. So I would say it's only fair to allow those vaccinated to do all these things, cross country, go cross borders, and go overseas, and dine in, and start working, and things like that. And unless there are specific reason for someone for not being vaccinated, and we know there are valid reasons as well. Someone who has got very severe allergy, or anything that's comorbidity. I'm not sure if any specific comorbidity that they are not supposed to be, they cannot be vaccinated. So unless it's for medical reasons, I think it's fair to have this vaccine passport. So if there is a medical reason, then carry a certificate that I cannot be vaccinated because this. So please allow me to dine in, and with SOPs or what. So I think it's only fair, because there is already a solution. And if someone don't want to take the solution because of human right, now, okay, this happened in the US, where the land of human rights, right? Now, it is your human right to not to wear a mask. It is your human right to not to vaccine, but it's also my human right to protect myself.
Right.
So if you are my employee, my staff, my colleague, it's my human right to say, don't come to the office because you're not vaccinated. So it's only fair, right? It works both ways. Human right works both ways. Yeah.
Correct.
So I that's my view on this.
Okay. I think finally, I would ask, how do you envision science communication to be incorporated in our daily lives? Now, you did mention that, more often, we talk about it often, we talk about it at our dinner table, but if you were to vision a perfect future where science communication is within our daily lives, it is something that is very, very normal. So what are the things that we don't have right now that we might have?
Well, this is my wish list. I wish we have more science centers. Of course, this is supposed to be by the government. There are private science centers as well. We've got the petroscience, we've got the planetarium. Planetarium is more government, petroscience is more private. So we need more of those. We need more musical, we need more theaters, science theaters, we need more science programs, on TV. So it's not only meant for the public, but for the students, but also for general public. As I said, the participation from the parents and from the teachers, and just giving a science topic where people, children and adults can talk about it. So I think these are the things that we need. Now, the Petri Dish, people can subscribe to it, go online and look at it and make it a tool and discuss at home. Then the Academy of Sciences have got st.my, ESTI.my. So that is another thing where I'm also the editorial board for that. And we put very simple things, but still the science is very strong, where again students, parents, teachers can all sit together. It becomes a platform. So these are the things that we need to do. I really think parents and teachers should play a big role, especially teachers who teach science and maths. Please make it inspiring. Don't make it for learning and just to pass the exams. Try to connect whatever you teach to the applications in real life. Pythagoras theorem, how is it applied in real life? Binary, how is it applied in real life? Reasoning and logics in mathematics, how is it applied in real life? So if that happens, then children are going to say, hey, yes, it's useful, science is useful, maths is useful. And I think that's my dream.
Right. Thank you so much, Dr. Maha. I think with that, we can wrap it up. Thank you so much for spending an hour with me. I had such an amazing time with you to be discussing this with you. It is a topic that I really love.
Thank you so much, Tammy. I hope our viewers enjoyed it too.
Yeah. It has been a pleasure. Thank you so much. Have a good night.
Good night. Good night, everyone. Good night, Tammy. Bye.
Bye. Okay, so thank you so much for those of you who are still watching. And don't forget to like and subscribe to Beacon Air resources, where you can find all the videos that I've done so far, all the episodes I've done so far. And if YouTube videos are not your thing, you can also find all the episodes on Spotify. And I will see you in 2 weeks. Till then, stay safe. Have a good weekend. Good night.